In this video, I'll be doing a brief overview of phosphorus pentachloride, covering things like its Lewis dot diagram, molecular geometry, and its bond angles. The formula for phosphorus pentachloride is PCl5, with one phosphorus being bonded to 5 chlorine atoms. Starting with the Lewis structure, we first have to count the total amount of valence electrons the molecule has, which will be 5 from the phosphorus, and then 7 times 5, which is 35, from the 5 chlorine atoms. Adding them all together will give us a total of 40 valence electrons that we have to represent in the Lewis structure. Since it's less electronegative than chlorine, we put phosphorus in the middle and then surround it with the 5 chlorine atoms. Because phosphorus forms 5 single bonds with the chlorine atoms, we have already used 10 valence electrons in the Lewis structure. Now the remaining 30 must be used to complete the octet for all of the chlorine atoms, which will give us the full Lewis structure for phosphorus pentachloride. Looking at the molecular geometry for phosphorus pentachloride, we can see that it has a trigonal bipyramidal shape with bond angles of 90 degrees and 120 degrees. I attempted to create this 3D model of the phosphorus pentachloride molecule that you can see here on the right while it's rotating around. Now, there are two types of atoms for this molecule with regards to the position of the chlorine. There are 3 equatorial atoms that have a 120 degree angle with each other, and there are 2 axial atoms. Now, if we look at the 2D visual, I can illustrate this a little bit better. The equatorial atoms are on the left and on the right, while the axial atoms are on the top and bottom. Like I said, the equatorial atoms have a 120 degree angle, but if we look at the angle between one of the axial atoms with an equatorial atom, we can see that it has an angle of 90 degrees, which means we have 2 different angles for this molecule.